Hello, friends, and welcome back to the Snoozy Scientist, where we gently explore the mysteries of our world, one sleepy yawn at a time. I'm so glad you've chosen to spend a little piece of your evening, your morning, or perhaps somewhere peacefully in between, winding down with me. Tonight, we're drifting back more than 700 million years to an age when the entire Earth was covered in ice. This was not a passing winter, or even one of the familiar ice ages humans would later endure. This was something far more terrifying, an endless freeze that locked the entire planet in white silence for 60 million years. Oceans froze, skies dimmed, forests and rivers vanished. Even the tropics, usually drenched in warmth and light, lay buried beneath glaciers miles thick. From the outside, Earth looked like a dead world, a blinding snowball drifting through the darkness of space. Scientists call this Snowball Earth, a catastrophe that plunged global temperatures below minus 40 degrees, covering the planet from pole to pole in ice and creating the longest and coldest ice age the world has ever known. Scientists believe Earth endured at least two of these frozen catastrophes during the cryogenian period, from about 720 million to 635 million years ago. The first was the Sturdian glaciation, which lasted a staggering 60 million years, longer than the entire age of the dinosaurs. The second, the Minoan, followed close behind, freezing the planet for another 15 million years. Together, they were the coldest ages in the history of Earth. By every measure, life should have ended here. Without sunlight, without rain, without warmth, survival should have been impossible. And yet somehow, against all odds, life refused to disappear. But how? How could anything endure 60 million years of frozen silence? What force could have driven Earth into such an icy prison in the first place? And perhaps most haunting of all, how did the planet ever escape? Tonight, we'll step softly into this forgotten world to uncover the story of when Earth became a snowball, of fragile life clinging to existence in the darkest corners, and how this ancient catastrophe may have been the reason complex life, including us, was able to exist at all. But before we begin, if you find comfort in these quiet journeys through science and story, it would mean the world to me if you gave this video a gentle like and maybe tapped subscribe. It helps more curious minds like you find their way to this peaceful little corner of the internet and lets the algorithm know that sleep and science belong together. And if you'd be so kind, let me know in the comments, where are you winding down from tonight and what time is it there? I love seeing how far across the world these soft explorations travel. Remember, as you listen, that without this frozen chapter, there may never have been us at all. Now take a deep breath. Let your shoulders soften. Close your eyes. And together, let's step softly into the forgotten age when Earth was swallowed by 60 million years of ice. Before the great silence of ice, Earth was already a restless place. If we could step back into that ancient world more than 700 million years ago, we would not recognize it as the home we know today. The continents were not arranged in any familiar pattern. Instead, they were welded together into a vast landmass called Rodinia. It was a supercontinent stretching across much of the globe, its mountains rising like scars across a barren and rocky landscape. But Rodinia was not destined to last forever. Deep beneath the crust, molten forces stirred. The tectonic plates creaked and shifted, tugging at the seams of this giant landmass until it began to tear apart. Cracks opened slowly, like wrinkles spreading across stone, until entire fragments of Rodinia drifted into the sea. This slow breakup of the supercontinent had profound effects on Earth's climate. The shifting land altered ocean currents, the winds that carried moisture, and the balance of gases in the air. All of these changes quietly pushed the planet closer to disaster, like a delicate scale tipping grain by grain. The world before the freeze would have felt strange to us in every way. There were no trees, no grass, no flowers. The continents were bare, windswept, and largely lifeless, except for mats of lichen and simple colonies clinging to the edges of rock. The land was empty, waiting for life that had not yet evolved. All the richness of existence was still locked away in the oceans. But the oceans of that time were not the bright blue seas we imagine today. They were alien realms, filled with strange chemistry and primitive creatures. Microbes and algae ruled the waters, drifting in massive numbers, their tiny bodies staining the seas with faint hues of green and red. These were the architects of Earth's early atmosphere, the slow workers that had begun releasing oxygen into the air. Yet, for all their importance, they were fragile and vulnerable, living on the thin edge of what their environment allowed. Imagine standing at the shore of such an ocean. The waves would have carried no fish, no shells, no plants swaying beneath the surface. Instead, the water would look murky, alive with swirls of microscopic life invisible to the eye. If you could scoop up a handful and look closely, you would see a world of floating cells, simple but abundant, endlessly multiplying in the sunlight. Life was already ancient by then, having survived for billions of years, but it remained small and delicate, not yet ready for the complexity that lay far in the future. It was a planet teetering on the edge of instability. The breakup of Rodinia exposed vast stretches of fresh rock, and those rocks eagerly pulled carbon dioxide from the atmosphere through weathering. Every mountain ridge, every new coastline became a silent vacuum, drawing down greenhouse gases that had kept the planet warm. Bit by bit, the air lost its ability to hold the sun's heat. The more the continents fractured, the more carbon was trapped away, and the cooler the planet became. This cooling did not happen in a single moment. It unfolded slowly, almost invisibly, across millions of years. But the effect was cumulative, like a long breath being drawn out of the atmosphere. The oceans themselves responded, changing their chemistry, altering how currents moved heat around the globe. Even the clouds shifted, becoming brighter, reflecting more sunlight back into space. These countless small changes worked together, nudging the Earth closer to a threshold that once crossed could not be undone. And yet, if we were there, it might not have looked like a world on the brink. The seas still shimmered with light, microbes still drifted in endless numbers, and the continents still stood tall against the sky. To the eye, it was a world alive and functioning, but beneath the surface, its balance was unraveling. The climate was becoming fragile, less stable, less forgiving. Earth was entering a dangerous game, one where a small push could set off a cascade of consequences. In this precarious state, the seeds of catastrophe were sown, the continents drifting apart, the seas ruled by microbes, the atmosphere slowly stripped of its greenhouse blanket. All of these forces combined into a planet, quietly preparing for one of the most extreme transformations in its history, a transformation that would soon bury the equator in ice and silence the oceans under a frozen lid that stretched across the world. The world before the freeze seemed calm on the surface, but deep within, forces were gathering that would change everything. Far below the crust, magma pulsed and shifted, feeding chains of volcanoes that dotted the continents and ocean floors. Each eruption spewed out molten rock and new land, but also played a quiet role in altering the very chemistry of the atmosphere. When fresh volcanic rock is exposed to the elements, it reacts with the air and water around it. Rainwater and wind wear it down, and in the process, carbon dioxide is drawn from the sky and locked away inside the rock. Normally, this process happens slowly, balanced by new emissions of carbon dioxide from volcanic eruptions. But in this ancient age, the balance began to tilt. Rodinia, the supercontinent, was tearing apart, exposing more and more raw stone to weathering. Volcanoes poured out lava in vast sheets, and the young rock that cooled from it was like a sponge, pulling down carbon dioxide in enormous amounts. Carbon dioxide is a greenhouse gas, and without enough of it, the Earth cannot hold on to its warmth. Every drop removed from the air weakened the planet's shield against the chill of space. The sun, already fainter in those times than it is today, could not provide enough energy on its own. The more carbon dioxide that vanished into the rock, the less heat remained near the surface. Slowly, almost imperceptibly at first, the air thinned of its greenhouse blanket, and the climate began to falter. The first signs of collapse would have been seen at the poles. Glaciers thickened, pressing out into the seas, their edges calving icebergs into waters that were already cooling. Snow fell more often, and the snow that fell stayed frozen instead of melting away with the seasons. White surfaces reflected the sun's rays back into space, a cruel feedback loop that only deepened the cold. Year after year, century after century, the ice crept forward. What had once been tundra became glacier. What had once been temperate forest became frozen plain. Entire regions locked in ice that refused to release its grip. Slowly, the frozen edges spread farther and farther until even the temperate zones that had once felt safe were shivering under sheets of frost. Imagine the tropics, the lush band of warmth that circles the middle of the earth, transformed into a land of ice. Imagine jungles erased, shorelines turned to frost, and beaches buried beneath glaciers that stretched for miles. Palm-like algae that had drifted in warm seas now suffocated under frozen lids of ice. The equator, a place we associate with heat and abundance, began to resemble Antarctica, silent and frozen, a place of relentless cold. It would have been a slow catastrophe, unfolding over millions of years, yet to the life that depended on stability, it must have felt sudden and terrifying. Microbes that had lived in sunlit waters found themselves cut off from light. Whole ecosystems that had balanced delicately on warmth and moisture now faced a creeping death as their world hardened around them. And still, the ice advanced, indifferent and unstoppable. The earth was entering a spiral that fed upon itself. The more the ice expanded, the more sunlight was reflected back into the void. The less sunlight absorbed, the colder the air and seas became. What had once been a stable climate was now a runaway freeze, each stage of cooling unlocking the next, each layer of ice making the return to warmth less and less possible. From space, the change would have been clear. The poles gleamed white, then the mid-latitudes, then even the tropics. The oceans shimmered with growing sheets of ice, and the continents glittered under permanent snow. Earth was slipping, slowly but surely, into a prison of frost. The collapse had begun, and with every century that passed, the world moved closer to a point of no return. The delicate balance of carbon and climate had tipped, and the consequences were spreading across the globe. The atmosphere that once cradled life was no longer enough to fight off the cold, and the planet edged toward the silence of a frozen age. As the ice spread out from the poles, swallowing coastlines and creeping steadily toward the tropics, the oceans themselves began to change in ways that life had never faced before. At first, it was the surface that froze, thin sheets of ice clinging to the edges of the seas. Over time, those sheets thickened, spreading wider, pressing farther out, until entire oceans lay buried under a lid of frozen water. What began as fragile crusts soon grew into barriers of ice, so thick they could entomb the seas beneath them. Imagine standing on the shore of what had once been a vast open ocean. Instead of rolling waves and the crash of surf, there is only silence. The water has become a frozen plain, stretching endlessly to the horizon, white and glittering under a pale sun. Where ships might one day sail, there are only ridges of ice. Where tides once rose and fell, there is nothing but stillness. The sea is no longer liquid, no longer free, but trapped under miles of frozen weight. This lid of ice did more than seal away the waters, it cut the oceans off from the sky above. No sunlight could pierce through, no warmth could filter down. The delicate balance that had sustained life in the upper layers of the sea was shattered. Tiny microbes and algae, once thriving in sunlit waters, could no longer carry out photosynthesis. The green glow of life in the shallow seas dimmed, then faded until the surface waters were barren and lifeless. The silence spread down into the depths. Without photosynthesis, the very base of the food chain collapsed. Creatures that depended on the energy of the sun starved. Whole ecosystems built on fragile exchanges of light and nutrients crumbled. It was the first great mass death of Earth's biosphere, a quiet unraveling that stretched from coastlines to the deepest trenches. Life in the oceans had always been resilient, but now it faced an enemy it could not resist. The ice was relentless, unfeeling, and absolute. It pressed downward with unimaginable force, thick enough to smother the seas, thick enough to block every flicker of sunlight. Beneath it, the oceans grew cold and dark, transformed into tombs where countless organisms perished unseen. Yet the oceans were not uniform in their fate. Near the surface, where the ice cut off the sun, the collapse was swift. But deeper down, far below the reach of light, even in warmer times, other forms of survival clung on. Hydrothermal vents continued to spew heat and minerals into the abyss, creating strange oases where microbes lived, not on sunlight, but on the chemistry of the earth itself. Around those vents, life endured, even as the rest of the seas became silent. Still, the scale of death was immense. Never before had life faced a challenge so global, so complete. The biosphere, once humming with microscopic activity, fell quiet. The oceans that had been nurseries for countless forms of existence became graveyards locked beneath ice. Every new sheet that spread across the waters tightened the noose, trapping heat below, preventing circulation, and sealing away life from the sky. From space, Earth would have appeared dazzling, a brilliant orb of white glistening in the darkness. But beneath that beauty lay devastation. The seas that once shimmered blue were entombed, their surfaces hardened into frozen shells. The planet's heartbeat, its oceans, had slowed almost to a stop, and still the ice grew thicker. It did not rest once the first layers were in place. It piled higher, compacting itself into walls that stretched downward, perhaps half a mile deep in places. The weight crushed the waters beneath, darkening them further, isolating them more completely from the life-giving sun. It was not a single ocean that suffered this fate, but every sea across the world, from pole to equator, each one buried in the same suffocating stillness. This transformation marked a threshold. Once the oceans were locked in ice, the earth had stepped firmly into its prison. The cascade of loss would not stop with the microbes that fed on sunlight. Larger organisms dependent on those microbes would starve in turn. Chains of life, fragile and interconnected, broke one after another. It was not a sudden collapse in a single instant, but a drawn-out fading, a long unraveling of the living world. The oceans, which had once carried the promise of abundance, now carried silence. With their surfaces sealed, with their light stolen, they became monuments to the fragility of life. And as the seas froze, the land too was falling into stillness, waiting for the weight of the coming silence to cover it completely. The oceans were sealed away, hidden under their thickening lids of ice, and with them went the sound of waves, the rhythm of tides, and the shimmer of blue that had once wrapped the planet in color. On land, The transformation was no less absolute. Rivers that had once cut through valleys froze in place, locked into rigid channels that would never flow again. Waterfalls stiffened into curtains of ice, their spray turned into frozen daggers clinging to stone. Rain no longer fell from the skies. Clouds thinned and vanished, leaving only a pale light from the distant sun that spilled over a barren and breathless world. The sound of earth changed. The rushing of rivers, the patter of rain, the soft percussion of water meeting soil, all of it fell away. In its place there was silence, broken only by the groaning and cracking of ice as it spread its grip across continents and seas. It was a silence heavy with finality, as if the planet itself were holding its breath. The air was dry and sharp, the winds carrying only the hiss of frost across plains that had once echoed with liquid life. Imagine walking across such a landscape. Beneath your feet, nothing but ice and snow, stretching outward in every direction, reflecting the pale light in blinding sheets. The ground no longer soft with soil or grass, but hard and brittle. Mountains, once jagged with rock and shadow, were softened by glaciers that blanketed their peaks, valleys filled not with rivers, but with ice compressed into solid walls that cut through the land. It was a planet reshaped, remade into silence and stillness. From above, the transformation was even more striking. Earth, once painted with blues and greens and browns, had become a dazzling orb of white. From the darkness of space, it must have glimmered like a frozen pearl, gleaming brighter than ever before. But the beauty was deceptive, because beneath that white shell lay devastation. What looked radiant from afar was up close a world stripped of warmth and movement. The reflection of sunlight back into space only deepened the freeze, locking the planet into its icy prison. This frozen earth would have inspired awe, but also dread. To gaze upon it was to see a planet that looked lifeless, as if it had always been destined for silence. The equator, usually the warm belt that carried the promise of life, was indistinguishable from the poles. The entire globe was uniform, blank, and blinding, with no trace of the diversity that once marked its surface. To look at Earth, then, was to wonder if it had ever truly been alive. On the continents, there was no greenery left to break the monotony. No forests whispered in the wind. No plants reached toward the sky. The land was empty, smothered in endless snow. Even the smallest streams, the trickling lifelines that once cut through stone, had frozen solid. They stood like veins without blood, reminders of a heartbeat that had stopped. The skies above carried their own silence, without the rise of vapor from the seas, without the rhythm of clouds forming and dissolving. There was little left to stir the atmosphere. Storms did not gather, thunder did not rumble. The air was thin, still, and colorless. Only the cracking of ice sheets, echoing like distant thunderclaps, gave the impression that the world was not entirely mute. For any creature, if such a creature could have stood upon this frozen earth, the experience would have been overwhelming. The glare of light reflecting off the endless snowfields would burn the eyes. The bitter cold would cut through even the deepest layers of protection. The horizon offered no comfort, no variation, only the repetition of white upon white. The very concept of seasons had vanished. There was no spring to bring relief, no summer to offer warmth, no autumn to soften the air, only winter without end. From the perspective of the stars, Earth had become a blinding beacon of cold. It was a vision of extremes, beautiful in its clarity, terrifying in its emptiness. Planets elsewhere might have looked similar, ice-covered and silent, but for Earth this was a departure from the life-filled world it had been. The transformation was profound, the contrast heartbreaking, and yet, beneath the silence, beneath the stillness, beneath the lid of ice, something persisted. Tiny sparks of life continued in places unseen, deep in oceans where heat and chemistry still offered a flicker of survival. The planet's surface looked like death, but its heart had not stopped completely. The white marble floating in space appeared lifeless, yet hidden within its silence were whispers of defiance. The planet was no longer one of flowing rivers and singing rains. It had become a frozen monument, dazzling, stark, and quiet, its beauty masking the peril beneath. The silence was not an end, but a pause in the great unfolding story of Earth. And as the glaciers thickened and the snow piled higher, the world sank deeper into its long sleep, waiting for the next turn in its ancient rhythm. With the continents buried under snow and the oceans sealed away beneath thick slabs of ice, the next great silence began to fall over the planet. It was not only the rivers and the seas that froze, but also the invisible system that once tied land and sky together. The hydrological cycle, the endless exchange of water that gave the world its pulse, was faltering. In warmer ages, sunlight had lifted water from the surface of the seas. Vapor drifted upward, gathering into clouds that softened the skies. Storms rolled across valleys, dropping rain that carved rivers through the land. Snow fell on mountains and melted into streams that fed forests and grasslands. Every drop of water was part of this constant rhythm, moving from ocean to sky to land and back again. But under the grip of global ice, this rhythm fell apart. The oceans were no longer open to the air. They were sealed beneath frozen lids that stretched from horizon to horizon, shutting off the vast reservoir that had once evaporated into the atmosphere. Without evaporation, the clouds disappeared. The skies became barren, stripped of their white veils. Where once storms had rumbled, there was only pale sunlight shining through thin, dry air. The sound of rain, a sound as old as life itself, was gone. With no clouds, the world grew eerily still. There were no shifting shadows racing across the ground, no bursts of thunder, no soft drizzle soaking the soil. The sky itself seemed motionless, a blank dome that offered no promise of relief. Without rain to feed them, rivers dried into empty beds of ice. Lakes vanished beneath their frozen covers, no longer filled by runoff from the land. The great cycle that had tied ocean to sky to land had stopped turning, as if the earth itself had lost its heartbeat. Imagine standing in such a place. Above you, the sky is wide and empty, not even streaked with thin cirrus clouds. The air feels sharp and dry, as though every trace of moisture has been stripped away. Beneath your feet lies a sheet of ice, cold and unyielding, stretching far into the horizon. Nothing flows, nothing moves. There is no rainfall to wash the land, no snowmelt to carve valleys, no river to guide your path. The world has become still, as if locked outside of time. This collapse turned Earth into something unfamiliar, something that can only be described as a frozen desert. It may seem strange to pair those two words together, for we imagine deserts as places of heat and sand. Yet a desert is defined not by warmth, but by absence. It is absence of water, absence of rain, absence of renewal. And in this age, Earth had become the greatest desert of all, stretching across continents and oceans alike, smothered by cold instead of heat, barren not with sand, but with endless ice. The land, which had once carried rivers through its valleys, now lay empty and dry. Snow might have fallen in rare places, but it never melted, never flowed, never joined into streams that gave life. It only added to the stillness, layering the silence higher and higher. The mountains gleamed under their frozen crowns, but the valleys below lay lifeless. Without the motion of water to sculpt them, they froze in place, unchanged year after year. Even the atmosphere itself was transformed. Water vapor, once the breath of the sky, had been stripped away. The air grew thin and brittle. Without vapor, Clouds could not gather, and without clouds, storms could not rise. The climate became fixed, locked in its frozen state. The air moved, yes, but it moved without purpose, carrying no moisture to the land, carrying no promise of rainfall. The earth had become still in its most fundamental cycle. The planet that had always carried water from place to place, always shifting it from ocean to cloud to stream, now carried nothing. The hydrological cycle, the great unseen system that had sustained life for billions of years, was broken, and in its absence, Earth's silence deepened. Yet even in that silence, in that frozen desert, the story was not over. The collapse of the water cycle did not mean the end of all life. For in places hidden from the surface, in places untouched by the frozen skies, there were still faint flickers of survival. The oceans locked beneath their lids of ice held secrets. Deep below, volcanic heat still stirred, and though the surface lay dry and still, far beneath, life was whispering its defiance in the dark. With the skies emptied of clouds and the rivers stilled into silence, it might have seemed as though life had finally reached its end. From the surface, Earth looked dead, a frozen marble locked in endless night. The continents were blanketed in ice, the oceans sealed under their heavy lids, the atmosphere stripped of the water that once gave it breath. To any eye looking down from the stars, the world would have appeared lifeless, abandoned, and cold. But life has always been stubborn, and even in this greatest of trials, it found ways to endure. Beneath the crushing weight of the frozen seas, deep in the blackness where sunlight had never reached even in warmer ages, there were cracks in the ocean floor. Along those cracks, water seeped into the fiery crust below and returned as jets of heat, rising in dark plumes. These were hydrothermal vents, towers of stone and mineral that poured out warmth and chemicals into the frigid deep. Around them, tiny worlds formed, worlds that owed nothing to the sun above. Instead of living on light, these organisms lived on the raw chemistry of the earth itself, feasting on hydrogen, sulfur, and iron. Here, in the shadows of these vents, microbes continued their quiet work. They thrived where all else failed, weaving fragile chains of survival in an ocean that had otherwise been sealed into silence. Even as the surface froze, even as photosynthesis collapsed, these chemosynthetic communities carried on, their lives flickering like candles in a dark room. In the grand emptiness of the oceans, they were small beyond comprehension, yet they were enough. Not all survival was hidden in the deepest trenches. On the surface, though the land was smothered and the skies were barren, there were places where heat still pulsed through the ice. Volcanic activity created rare sanctuaries, pockets of warmth where the earth itself pushed back against the cold. Lava pools glowed in the frozen darkness, steaming against the glaciers that pressed around them. In such places, the ice melted into thin lakes of liquid water, and the warmth allowed tiny oases to exist. Within them, microbes huddled close, clinging to life where everything else had perished. These volcanic pools were fragile, surrounded by cold on every side, yet they were havens. They gave life a chance to hold on, even if only in microscopic form. Imagine a tiny pond of warmth glowing against a continent of ice, its surface steaming faintly in the frigid air. To us, it would seem insignificant, but to the microbes within it, it was a universe of survival, a place where the story of life could continue unbroken. Life also adapted in ways that defied the harshest conditions. Some microbes developed strategies to endure the eternal night. Instead of relying on sunlight, they harvested energy from the simplest reactions of chemicals. Others slipped into dormant states, curling inward to wait out the freeze, capable of surviving for years without activity, only awakening when conditions briefly softened. They were small, unseen, and fragile, yet in their persistence they were unyielding. The surface of Earth was silent, the skies empty, the oceans locked away, but hidden deep below, there was still movement. Warmth rose from vents, gases hissed from cracks, and in these places life clustered. It was not the flourishing life of forests or coral reefs, not the abundance of a vibrant world, but rather the thin thread of existence stretched across impossible odds. It is easy to imagine the Earth as lifeless in this age, a frozen pearl adrift in space, but within it were countless tiny sanctuaries where survival refused to yield. Every crack of volcanic heat, every plume of chemical-rich water, every hidden pool kept life alive, even as the rest of the planet lay still. These refuges were not visible from above. They could not be seen from the stars, yet they were enough to carry life forward through 60 million years of deep freeze. And so, while the world remained imprisoned in its frozen silence, there were still sparks of defiance, small but enduring. The microbes that clustered around vents and volcanic pools did not know they were preserving the future. They did not know they carried the seeds of all life to come. Yet in their survival, quiet and unseen, they held the key to Earth's story continuing, waiting for the day when the ice would finally loosen its grip. The ice did not come and go with the rhythm of seasons. It did not retreat after a few centuries, or even after a few millennia. Once the Earth was sealed in its frozen shell, it stayed that way for an almost unimaginable stretch of time. Scientists call this frozen age the Sturdian glaciation, and it lasted for around 60 million years. To us, 60 million years is a number so vast that it is almost impossible to hold in the mind. It is not the span of a human lifetime, or of a civilization, or even of our entire species. It is a stretch of time longer than the distance that separates us from the last of the great dinosaurs. For perspective, humanity has existed for roughly 300,000 years. That is a blink compared to the endless winter of the Sturdian glaciation. Every story humans have ever told, every empire ever built, every work of art or leap of science has happened within that brief span of 300,000 years. Now imagine a cold that did not relent for 60 million. 60 million years is long enough for mountains to rise and wear down again, long enough for oceans to shift their shores and carve new coasts, long enough for entire lineages of creatures to appear and vanish. Yet through all of it, the world remained frozen, unyielding, silent. Life, such as it was, endured in that stillness, but to call it living hardly captures the reality. These organisms were trapped in a kind of stasis, surviving on the barest threads of possibility. Generations rose and fell within the shadows of hydrothermal vents or in the rare volcanic pools that dotted the frozen landscape, yet for each new generation the world outside remained unchanged. Microbes were born, multiplied, and died in darkness, while above them the planet carried on as a glistening marble of ice. Imagine what 60 million years means in terms of generations. If a microbe divides every day, then 60 million years is not thousands or even millions of generations, but trillions. Entire unbroken chains of life, cycling through birth and death, carrying forward the tiniest spark of existence without pause. To those microbes, the frozen world was all they knew. The sunless oceans, the chemical heat of vents, the occasional pools of volcanic warmth, these were the boundaries of their universe. Outside them, the earth lay in silence, waiting. It is haunting to picture such a time. The surface of the world was empty, stripped of motion and sound, yet beneath it countless generations of life clung on, their persistence invisible to the stars. They endured without any sense of the scale of their trial, without any thought that millions upon millions of years were passing in the same cold silence. Theirs was not survival as we think of it, active and striving, but survival reduced to the simplest act of continuing, no matter how long the winter lasted. This was the longest continuous ice age in Earth's history. Never before and never since has the planet been locked for so long in one unbroken season. If you had stood on Earth at the beginning of the freeze and then somehow returned 60 million years later, you would have seen nearly the same sight: white horizons, silent glaciers, sealed seas. Mountains might have shifted, valleys might have deepened, but the ice would still have been there, holding the world in its grip. The scale of time is almost unbearable to contemplate. We measure our lives in decades, our histories in centuries, our civilizations in a few thousand years. Yet this winter stretched 60 million. That is 200 times longer than all of recorded human history, and through every moment of it, the earth remained in suspension, its waters silent, its skies empty, its lands unmoving. Life did not flourish in this age. It did not expand or diversify or build new forms. It simply endured, waiting in stillness, generation after generation after generation. The microbes that clustered in those hidden sanctuaries did not know they were keeping the thread of life alive. They simply carried on, unaware that their endurance across 60 million frozen years was writing the foundation for everything that would come after. And still, beneath that weight of time, the earth held onto more than silence, for deep within the planet, forces were still moving. Volcanoes still erupted, heat still rose from cracks in the crust. Beneath the frozen surface, the story was continuing, preparing for the next great shift in the planet's history. For millions upon millions of years, the earth lay trapped in silence, its surface smothered in ice, its oceans sealed in darkness. Yet even while the world above seemed frozen in stasis, the heart of the planet still beat with restless energy. Beneath the crust, heat stirred, magma shifted, and pressure built. The earth had not gone cold inside. Fire still lived beneath the ice. Volcanoes were the scars where that inner fire broke through. They rumbled beneath the glaciers, their eruptions muffled by the weight pressing down from above. Some spewed their fury under the oceans, unseen in the black depths, releasing plumes of heat and gases into waters already starved of life. Others cracked through the frozen continents, fountains of lava forcing their way against the cold. Each eruption was a reminder that the planet was alive, even if its surface seemed lifeless. Every burst of volcanic fire released something far more powerful than molten rock. Carbon dioxide poured into the air, adding to the atmosphere molecule by molecule. For as long as the ice held, the planet's rocks could no longer absorb that gas through weathering. The normal balance of carbon had been broken. With every eruption, the greenhouse gases lingered, slowly building, slowly pressing against the endless grip of the cold. These eruptions also brought change to the frozen surface. When lava met ice, it created pockets of warmth that seemed almost miraculous in their rarity. Glaciers hissed and steamed as rivers of molten rock slid across their surfaces. For a brief time, the cold was broken. Pools of liquid water gathered near the flows, steaming against the frozen silence, offering temporary havens. These small oases were not enough to change the global freeze, but they gave life tiny footholds, fragile sanctuaries in a desert of ice. Picture such a scene, a landscape of endless white, silent and frozen, broken suddenly by a wound of red fire. Lava spills into the cold air, its heat cracking the ice and sending clouds of steam into the sky. Around it, pools of meltwater gather, liquid against all odds. For microbes drifting in the frozen wastelands, such places were salvation. Here, chemical reactions could flourish. Here, life could cling more easily than in the suffocating dark beneath the glaciers. These were fleeting, fragile oases, yet they carried significance beyond measure. Survival in this age did not come from stability, but from chaos. The ice pressed down with uniform stillness, but it was the unpredictable, violent eruptions of volcanoes that gave life its chances. Chaos created warmth, chaos created cracks in the silence, and in those cracks, life endured. Beneath the oceans, the story was much the same. Submarine volcanoes, unseen and unheard, spilled their heat into the abyss. Around their vents, chemicals surged into the water, feeding the strange ecosystems that thrived in darkness. For microbes, these eruptions were not disasters but gifts. They turned lifeless regions into pockets of abundance. They created the raw materials from which survival was built. The earth, though frozen on the surface, was restless within. The return of fire beneath ice was not a constant steady flame, but a series of bursts and spasms, unpredictable and fierce. Each eruption was destructive in its way, yet also life-giving. For without them, the ice might have been absolute. Without them, the planet might have sunk into permanent silence. Instead, the fire provided just enough chaos, just enough disturbance to keep survival possible. Over time, the gases that escaped from these eruptions accumulated. Carbon dioxide thickened in the atmosphere, invisible yet powerful. Slowly, the planet was being prepared for its eventual escape, though that end lay far in the future. For now, the ice still ruled, but the balance had shifted. Beneath the stillness of the frozen desert, chaos was working quietly, patiently, to tip the scales back toward warmth. The return of fire beneath ice did not end the longest winter, but it kept the flame of survival alive. It created oases where none should exist, and it laid the groundwork for the thaw to come. And so the frozen planet, seemingly lifeless, was not entirely silent. It was a world of opposites, fire against ice, chaos against stillness, survival hidden in the tension between destruction and creation. The story of Snowball Earth might sound too strange to be true, but the evidence lies hidden in the oldest layers of stone. For millions upon millions of years, rocks have carried silent records of the planet's past, etched into their grains, locked into their chemistry, preserved as messages for those who would one day learn to read them. To understand how Earth froze solid, how life endured, and how the world eventually thawed, scientists turn not to imagination, but to the testimony of stone. One of the most striking clues comes from what geologists call drop stones. These are large chunks of rock that do not belong in the layers where they are found. Picture a boulder or cobble sitting inside fine layers of ancient mudstone. The only way such a stone could appear there is if it had been carried by a glacier, lodged into a floating iceberg, and then dropped into the sea when that iceberg melted. Today, we see such stones in high latitudes, where icebergs still calve into cold oceans. But in the case of Snowball Earth, drop stones have been discovered in places that were once near the equator. That means glaciers must have reached all the way from the poles down into the tropics, carrying stones with them before releasing them into waters that should have been warm. The presence of those stones, embedded in the sediment, is proof that the freeze was global, not regional. Other clues are hidden at the microscopic level in the very chemistry of the rocks. Scientists study isotopes, subtle variations of common elements, which act like fingerprints of ancient conditions. Carbon isotopes, for example, can reveal whether life was active in the oceans at a particular time. During the frozen ages, the ratios of these isotopes show that life never fully vanished. The signals suggest that microbial activity continued even while the surface was locked in ice. These fingerprints tell us that while most of the biosphere collapsed, pockets of survival remained, clinging on in the hidden corners of the world. The rocks quietly confirm what life itself demonstrated: endurance against impossible odds. The most haunting clues, however, appear not in the rocks that formed during the freeze, but in those that came after. Once the ice finally began to melt, the oceans were left brimming with carbon dioxide that had built up in the atmosphere for millions of years. When the glaciers retreated, those gases rushed into the water, fueling an explosion of chemical reactions. The result was the formation of thick layers of carbonate rock deposited rapidly across the globe. These are called cap carbonates because they sit like a lid directly on top of the glacial deposits. They mark the precise moment when the world emerged from its icy prison. To find them is to find the line in stone that separates the silence of Snowball Earth from the chaos of the thaw. Imagine standing in front of a cliff face that has been cut open by erosion. Within the layers of sediment, you can trace the story. First, the glacial deposits filled with drop stones, telling of ice that reached to the equator. Above that, a sharp boundary where the ice vanished, capped by bright carbonate stone laid down in a geological instant. These layers are not myths. They are physical, tangible records that you can touch with your hands, evidence of a planet that froze solid and then awakened again. Each piece of evidence fits together into a single picture. The drop stones prove the ice was global. The isotopes prove life never died. The cap carbonates prove that when the thaw came, it was sudden and overwhelming. The rocks are not just silent witnesses. They are storytellers, holding the memory of events so ancient they predate animals, predate plants, predate even the earliest complex life. Without them, the idea of Snowball Earth would be speculation. With them, the picture becomes clear, a frozen chapter preserved in stone. The Earth may have seemed lifeless during those millions of years, but the rocks tell us otherwise. They speak of glaciers sliding across the tropics, of microbes refusing to vanish, of oceans bursting with change when the thaw finally came. And as we follow those clues deeper into the planet's memory, we begin to understand not only how Earth survived, but how that survival set the stage for everything that followed. The rocks tell us that glaciers reached the equator, that oceans were sealed beneath ice, and that the planet was transformed into a white marble glistening in the dark. But even with all this evidence, one haunting question remains. Was Earth completely frozen, a true hard snowball, or did it retain tiny pockets of open water, making it more of a slush ball than a perfect sphere of ice? The answer is not only a matter of geology, it changes how we imagine survival itself. The hard snowball theory envisions Earth locked under ice from pole to pole, with glaciers and frozen seas covering every inch of the planet's surface. In this version, no sunlight could reach the waters below. No evaporation could rise to form clouds. No rivers could flow across the land. It was a world entirely suffocated, with life surviving only in deep, hidden sanctuaries near volcanic vents or geothermal oases. To stand on such a planet would have been to see nothing but endless white, the horizon swallowed in ice, the silence absolute. But there are scientists who suggest this picture may be too complete. They argue that while most of the oceans froze, there could have been thin stretches near the equator where the ice was not as thick, or even small puddles of open water where the sun still touched the sea. In this slush ball scenario, the ice still wrapped the world, but it was patchy in places, leaving fragile windows of liquid ocean exposed. Such areas would have been rare, but they might have made a crucial difference. If open waters existed, even in the smallest amounts, they would have allowed sunlight to penetrate the ocean's surface, feeding tiny algae and microbes with the energy they needed. The food chain would not have collapsed as completely. Instead of life surviving only on chemical reactions in the dark, photosynthesis might have continued in hidden corners of the seas. These equatorial puddles would have been refuges of a different kind, small sanctuaries of light in a world otherwise drowned in shadow. Imagine the contrast. In the hard snowball vision, survival depended entirely on Earth's inner fire, on volcanoes and hydrothermal vents, on chemistry replacing sunlight. Life would have been pushed to its limits, barely clinging on in the smallest cracks. But in the slushball vision, survival also had the faintest help from the sunday. Tiny areas of open water would have kept ecosystems alive, preserving a link to the surface world even as the planet froze. The debate between these two visions has been ongoing for decades. Both sides point to clues, yet neither can claim final proof. The presence of drop stones at the equator suggests the ice was thick, carried by glaciers that floated in seas sealed by frozen lids. But the isotope signals in the rocks show that photosynthesis never stopped entirely, which could mean life endured in cracks of ice, or it could mean sunlight still reached some scattered open waters. The rocks whisper possibilities, but they do not tell us everything. Each theory reshapes the survival story. If Earth was a true hard snowball, then life endured one of the most extreme trials imaginable, adapting to a planet where the sun could no longer reach the seas. The endurance of microbes in complete darkness, generation after generation, would be one of the greatest feats of resilience in Earth's history. But if Earth was instead a slushball, then the story is one of fragility and luck, with life finding its way in rare puddles of open sea, depending on patches of sunlight that refuse to disappear entirely. Both versions are humbling. Both remind us how precarious life was in that frozen age. Whether clinging to volcanic heat in the abyss or surviving in equatorial pools of thin water, life was pressed against the edge of extinction, yet refused to let go. The difference lies in how narrow that edge was. Was it a thin thread, almost impossible to cross, or was it a fragile web, still supported in places by the faint touch of the sun? The truth may never be fully known. Perhaps the Earth shifted between both states, at times a hard snowball locked in suffocating silence, at other times a slushball offering fleeting windows of open water. Perhaps the planet's balance wavered, teetering between total freeze and fragile thaw. What we do know is that, however the details unfolded, survival was never easy. Every life that endured did so against unimaginable odds, carrying forward the fragile story of existence into the ages that would follow. The end of the Sturtian glaciation was not the end of Earth's trials. After 60 million years of silence and ice, the planet slowly began to thaw. Volcanoes had poured carbon dioxide into the atmosphere for so long that eventually the greenhouse effect overwhelmed the reflective power of the ice. Glaciers retreated, oceans reopened, sunlight returned to the waters, feeding photosynthesis once again. For a time, it must have seemed as though the nightmare was over, but the Earth was not finished with its deep freeze. Barely 10 million years after the thaw, the planet slipped once again into a global glaciation. Scientists call this second catastrophe the Marinoan glaciation, and it lasted for around 15 million years. While shorter than the Sturtian, it was still a span so vast that it dwarfs all of human history many times over. This was not a passing relapse. It was another apocalypse, complete in its reach, with ice once again encasing the world from pole to equator. Why would Earth endure not one, but two, such frozen imprisonments in such close succession? The answer lies in the delicate balance of the planet's climate system. When the Sturtian ended, the atmosphere was thick with greenhouse gases, enough to tip the planet back toward warmth. But in the chaos that followed, the cycle of weathering and carbon capture began again. The newly exposed rocks of the continents eagerly pulled carbon dioxide from the sky, dragging the atmosphere back toward fragility. Slowly, the greenhouse blanket thinned once more, and with each molecule removed, the planet edged closer to collapse. Eventually, the scales tipped, and the cycle repeated. The Marinoan glaciation was, in some ways, even more dramatic than the first. The layers of stone that record its passing show thick bands of glacial deposits, just like those of the Sturtian, but with subtle differences that tell of shifting conditions. Dropstones are once again found far from where they should be, proving that glaciers reached into the tropics a second time. The chemical signatures in the rocks once again show the fingerprints of life surviving against the odds, tiny signals of microbial activity even as the surface lay frozen. One of the most striking pieces of evidence comes from the layered rocks themselves. Imagine slicing into the Earth's crust and seeing alternating bands, one recording the silence of the Sturtian, another marking the chaos of the thaw, and then another repeating the story with the Marinoan. These bands are like pages in a book, each one written in stone, each one telling of the planet's frozen relapses. They are not gentle records. They are abrupt, thick, and global, showing that the Earth did not stumble into regional freezes, but was engulfed in total transformations. The Marinoan also left behind its own cap carbonates, marking the moment when the thaw came again. These layers sit directly on top of glacial deposits, proof of a sudden transition from ice to warmth. In some places, they are so thick that they can be measured in meters, evidence of chemical reactions unleashed when the greenhouse effect returned in force. They are monuments to the violence of Earth's swings, from frozen silence to sudden floods of life. To imagine two such events so close together is to realize how unstable the planet was in that age. The cryogenian period was not a time of balance. It was a time of extremes, of violent oscillations between states that nearly destroyed the possibility of life. That life endured through one global ice age is remarkable. That it endured through two is almost beyond belief. And yet, the rocks confirm it. The layers lie one atop the other, a repeating pattern of catastrophe. The Marinoan was the final act of the cryogenian, the second plunge into silence, before Earth emerged into a world transformed. These twin freezes are written into the crust, reminders that the path of life has never been smooth, but forged through cycles of collapse and survival. The second freeze was not merely an echo of the first. It was proof that the forces driving the planet were unstable, that even after tens of millions of years of ice, Earth was still vulnerable to falling back into silence. It was as if the world was testing life, pressing it again and again against the edge of extinction. And through it all, life held on, waiting for the age when the ice would finally retreat for good. The story of Snowball Earth is more than a tale of ice and silence. It is a lesson in balance, in how delicate the line between life and extinction truly is. Earth's climate is not a steady machine, humming smoothly no matter what. It is more like a seesaw, balanced precariously, tilting one way toward warmth, tilting the other toward cold. For billions of years, life has depended on that balance, yet time and again the scales have wavered dangerously. During the cryogenian, the seesaw tipped so far toward cold that it nearly ended the story of life altogether. The forces that control this balance are surprisingly small. A shift in the amount of carbon dioxide in the air, a change in how much sunlight the Earth receives, or even the position of the continents can send the climate spiraling. In the age of Snowball Earth, it was the slow drawdown of carbon dioxide that began the collapse. Fresh volcanic rock, exposed by the breakup of supercontinents, absorbed greenhouse gases from the atmosphere like a sponge. At first, the effect was subtle, invisible to the life clinging to the seas. But every molecule taken from the air reduced the planet's ability to hold heat. Over time, the seesaw tilted, the warmth slipped away, and the balance broke. Once the ice began to spread, another feedback loop locked into place. White surfaces reflected sunlight back into space, cooling the Earth further. The colder it grew, the more ice spread. The more ice spread, the colder it grew. It was a runaway spiral, a perfect example of how fragile the system was. A small push from falling carbon dioxide had been enough to set the planet on a path toward catastrophe, proving how thin the margin for stability truly is. Sunlight itself was another factor in this delicate dance. The sun of 700 million years ago was fainter than it is today, its light weaker by a few percent. That may not sound like much, but in a system as finely balanced as Earth's point, a few percent was the difference between habitability and collapse. The weaker sun meant the Earth was already closer to the tipping point. When greenhouse gases dropped, there was not enough solar energy to compensate. The seesaw leaned too far, and the planet plunged into ice. This fragility is terrifying to imagine. The Earth seems so solid beneath our feet, so vast and unchanging, yet its climate rests on a knife's edge. In the cryogenian, the smallest adjustments were amplified into global catastrophe. A slight decrease in carbon dioxide, a small shift in sunlight, or the movement of continents across latitudes, all of these forces nudged the balance. None of them alone could explain the entire freeze, but together they worked like invisible fingers, pushing the seesaw in one direction until it tipped. For life, this instability meant that existence was never guaranteed. Microbes, algae, and the earliest complex cells lived not on a stable stage, but on one that could collapse beneath them with little warning. The surface might seem calm, the oceans filled with light, the continents standing firm, but in the background, the balance was always fragile. Life clung to a planet that could turn hostile in an instant, a planet that nearly erased its own story, not once, but twice. Picture the Earth at that time as a child's toy, balanced delicately on a pivot. A single pebble dropped on one side, and the whole thing tips over. That is how the climate operated. A few parts per million of greenhouse gases lost to the rocks, or a fraction less sunlight reaching the ground, and the planet tilted into catastrophe. It was not a robust system, it was a fragile one, balanced so finely that small changes had consequences of unimaginable scale. And yet, this very fragility shaped the path of life. The pressures of collapse, the trials of survival, the near impossibility of continuing, all of these shaped the evolution of resilience. Without the razor's edge, without the terrifying closeness of extinction, life might never have been forced to adapt, to innovate, to prepare for the complexity that lay ahead. The same instability that almost ended the story was also what kept it moving forward. The Earth had shown just how precarious the stage of life really was. A planet that seemed eternal could in fact be pushed to the brink by the smallest shifts, and as the ice still gripped the continents and the oceans, that delicate balance continued to hover, waiting for the next turn, waiting for the moment when fire, gas, and sunlight would again tilt the seesaw toward warmth. The Earth of the Cryogenian did not orbit beneath the same sun we know today. Our star, though steady and constant in its daily rise and fall, has been changing over deep time. Billions of years ago it was weaker, shining with less intensity, pouring down less energy onto the planet below. This puzzle is known as the faint young sun paradox. By all calculations, a weaker sun should have left the Earth frozen solid from the beginning, and yet life arose and flourished long before the great ice ages of the Cryogenian. Something, perhaps greenhouse gases like carbon dioxide and methane, must have kept the Earth warm enough to remain habitable, but that fragile protection did not last forever. When the gases began to slip away, the dimmer sun revealed just how vulnerable the planet really was. Imagine the warmth of sunlight not as a blazing force, but as a thin and delicate thread stretched between the heavens and the Earth. During the Cryogenian, that thread was already weaker than it is today. The light that reached the surface was fainter by several percent, and in the balance of climate, those few percent made all the difference. Even slight changes in the way the atmosphere trapped heat, or in the way the oceans absorbed energy, could send the system tilting toward catastrophe. The seesaw of climate, already precarious, had lost much of its counterweight. Under this dimmer starlight, the Earth became far more vulnerable to freezes. Once ice began to spread, the weak sun could not fight back. White surfaces reflected its light away, bouncing precious warmth back into space. The colder the planet grew, the harder it became for the sun to push against the advancing silence. The faint young sun was steady in its light, but it was not enough. Without the greenhouse gases to hold in heat, the energy slipped away into the void, and the planet sank deeper into its frozen state. From a cosmic vantage point, this transformation would have been striking. Picture Earth as seen from space, not the blue and green jewel we know, but a dazzling sphere of white, gleaming brighter than any neighboring world. To an observer drifting beyond the solar system, Earth would have looked lifeless, its oceans invisible beneath miles of ice, its continents indistinguishable under glaciers. It would have resembled the frozen exoplanets we now discover orbiting other stars, worlds dismissed as barren because they appear locked in ice. It is humbling to realize that our planet once looked so dead from afar. If another civilization had peered across the light years and studied Earth in that age, they might have turned away, convinced it was sterile, incapable of harboring life. And yet, hidden in the cracks of volcanic heat, in the dark of the oceans, in rare pockets of survival, life endured, unseen and unsuspected. Earth wore the face of a frozen exoplanet, but its story was not over. The faint young sun paradox lingers even in our imagination. It forces us to think of the balance that made life possible as razor thin, held together by invisible forces that can be lost with the smallest change. Greenhouse gases saved the early Earth, wrapping it in a blanket strong enough to compensate for the sun's weakness. But once that blanket was stripped away by weathering and by the breakup of continents, the faint sun was powerless to prevent the descent into ice. This cosmic perspective reveals something haunting. From the scale of space, planets may appear dead when they are alive, or alive when they are near death. A frozen sphere may still whisper with survival beneath its surface. A bright blue marble may hide fragility within. In the age of Snowball Earth, our planet lived a double life, dazzling and lifeless to the eye, yet breathing in hidden places no telescope could see. The image of Earth as a white exoplanet drifting under a weaker sun is both beautiful and unsettling. It reminds us how easily our world could have remained that way, locked forever in silence, overlooked by the cosmos. The same faint starlight that nourished survival also exposed how vulnerable life truly was. And while the earth glistened as a frozen pearl in the dark, the story within continued, waiting for the fire and the gases beneath the ice to tip the balance once more toward warmth. For nearly all of Earth's history, life had drawn its energy from the sunlight. Microbes floating in shallow seas captured its light and turned it into food through photosynthesis. The rhythm of sunlight had been the foundation of existence, a steady pulse that connected the sky and the sea. But when the planet froze, that rhythm stopped. The oceans were locked under miles of ice, the skies were stripped of clouds, and the light that once reached the surface of the water was gone. It seemed as if life had lost its source of energy, its most basic lifeline. Yet even in the dark, life found another way. Beneath the frozen surface, deep in the oceans, cracks in the Earth's crust became refuges. From these cracks, jets of superheated water gushed upward, carrying minerals and gases from the mantle below. They were hydrothermal vents, strange chimneys built of minerals, spewing water so hot it could melt flesh, yet rich in the chemistry of survival. Around these vents, life turned away from the sun and embraced another form of energy. Instead of photosynthesis, it turned to chemosynthesis. Chemosynthesis is the ability to create food not from light, but from chemical reactions. Microbes clustered around the vents, feeding on hydrogen, sulfur, and iron that poured from the Earth's interior. They built energy from these raw ingredients, spinning life out of chemistry instead of sunlight. It was a miracle of adaptation, a reinvention of survival. The dark ocean floors became landscapes of microbial mats, thick carpets of living cells clinging to every surface near the vents. These mats were vibrant in their own alien way. To the eye, they would have looked like slick layers of slime spreading over rocks, glowing faintly with life in the deep blackness. But within them, countless cells worked together, dividing, multiplying, and passing energy along fragile chains of existence. Around them, other organisms found food, building entire ecosystems in the absence of light. Small creatures fed on the microbes, larger ones fed on them, and so on, forming webs of survival that had nothing to do with the Sunday. Imagine drifting in the abyss during that frozen age. Above you, miles of ice weigh down the ocean. Around you, there is no light, only the faint shimmer of minerals glowing in the hot plumes of the vents. Yet life swarms in these places, hidden in the deep. The vents hiss and roar, their warmth spreading into the water, while microbial mats cling tightly to every surface, feeding on the chemical fire that bursts from the Earth's heart. In this world of shadows, life endured not because of light, but because of the planet's restless energy. Even away from the great vents, volcanic heat created smaller oases. Pools warmed by geothermal springs allowed microbes to survive in isolation, clustered in mats, where they harvested what little chemistry was available. These communities were fragile, but they were lifelines. Each one was a tiny beacon of endurance, a reminder that survival can take root in the most unlikely of places. For the microbes themselves, the absence of the sun was not the end. They adapted, shifting their metabolisms, finding new ways to live. Some entered dormant states, wading through the worst of the cold, awakening when warmth or chemical fuel returned. Others evolved into specialists, perfectly suited for the abyss, thriving where sunlight never touched. Theirs was not an easy existence, but it was enough to keep the thread of life unbroken. The Earth looked lifeless from space, a frozen orb gleaming white under a weak Sunday. Yet in its depths, life clung stubbornly to volcanic heat, weaving its existence around the chemistry of sulfur and iron, whispering its defiance into the darkness. The great freeze had silenced the oceans above, but it could not silence the fire within the earth, and it was that fire that carried life through the longest night the planet had ever known. As the world lay trapped in its icy prison, one haunting possibility lingered. What if the Earth never escaped? Climate scientists today have run models of what happens when a planet freezes from pole to equator, and the results are sobering. Once the surface is locked in ice, sunlight bounces away almost completely. Instead of warming the ground and oceans, the energy of the star is reflected back into space. The more ice that spreads, the more sunlight is lost, and the colder the world becomes. It is a cycle with no easy exit, a trap so complete that some models suggest a planet could remain frozen forever. For the Earth of the Cryogenian, this fate was terrifyingly close. From space, the planet looked like a white mirror, shining brilliantly but giving nothing back. The sun, already fainter in that age, could not break through. Its rays were turned away before they could warm the oceans. Without greenhouse gases to hold heat in the atmosphere, the cold deepened and the silence thickened. It is not hard to imagine an alternate history where the Earth never left this state, where ice remained for billions of years until even the last microbes faded away, leaving behind a silent, glittering tomb. The only reason that did not happen lies within the restless heart of the planet. Beneath the frozen crust, volcanoes continued to erupt. Their heat melted small oases in the ice, but more importantly, they released gases into the sky. Each eruption sent out clouds of carbon dioxide, and unlike in warmer times, there was no liquid water or weathering rock to absorb it. Normally, rain and rivers would pull this gas back into the earth, locking it in stone, but under the frozen surface, with the water cycle broken and continents sealed, that system had shut down. The carbon dioxide that poured out of volcanoes lingered in the atmosphere, molecule by molecule, building a thicker greenhouse blanket. This slow accumulation was the planet's only chance. Without it, the Earth would have remained frozen. With it, the balance began, very gradually, to tilt. For tens of millions of years, volcanic gases continued to escape into the skies, invisible and silent, yet powerful enough to shift the course of the planet. At first, the buildup changed nothing. The ice still reflected the sun's light. The oceans remained sealed, but as the greenhouse gases grew denser, the air began to trap more and more of the little energy that did reach the surface. Imagine a blanket laid over a body in the cold. At first it feels thin, barely enough to make a difference, but add another, and then another, and warmth slowly gathers beneath. That is what happened with the Earth. Carbon dioxide layered over carbon dioxide until the atmosphere became thick enough to stop the escape of heat. The faint warmth of the sun, once useless against the ice, was now held in place. It collected slowly, melting began at the edges, and cracks started to open in the glaciers. The Earth had come dangerously close to permanent death, yet it was saved by the very processes that had once contributed to its collapse. The same tectonic shifts that exposed rocks to strip carbon dioxide away also fueled the volcanoes that restored it. The same inner fire that kept life alive in the abyss eventually rewrote the fate of the surface world. It was not a quick salvation. It took millions upon millions of years for enough gases to gather. But in the end, the Earth was pulled back from the brink. If the planet had been only slightly different, with fewer volcanoes or less tectonic activity, the outcome might have been final. Without the steady breath of carbon dioxide into the atmosphere, the sunlight's faint warmth would never have been enough. Earth would have remained a frozen pearl adrift in space, silent and empty, indistinguishable from the barren exoplanets we see orbiting other stars. Instead, by the narrowest of margins, It escaped. The balance shifted. The greenhouse blanket thickened. The planet stirred beneath its ice, preparing for a thaw that would not only end the silence, but open the door to a very different future. For tens of millions of years, the Earth lay trapped in its icy silence, the atmosphere slowly thickening with carbon dioxide released from volcanoes. Each eruption breathed more of the gas into the sky, invisible and patient, wrapping the frozen planet in a growing blanket of warmth. Nothing seemed to change at first. The ice still gleamed from horizon to horizon, the oceans remained sealed beneath their lids, and the air above was sharp and thin. Yet deep within the atmosphere, a quiet transformation was building. Eventually, the tipping point arrived. The balance that had once sent the world spiraling into cold now leaned the other way. The greenhouse gases had grown so dense that the faint energy of the sun could no longer escape into space. Heat began to gather, small at first, barely enough to soften the edges of glaciers, but over time it built with relentless persistence. The white marble that had reflected the sun's light so efficiently could no longer hold back the warming. Cracks appeared in the frozen silence. Once the first fractures opened, the change came quickly. Melting spread across the surface, and water pooled on top of the glaciers. Those pools absorbed sunlight instead of reflecting it, warming faster, cutting deeper into the ice. What had once been solid and unyielding began to collapse under its own weight. Rivers of meltwater carved their way through the frozen plains, burrowing downward until they reached the seas below. The oceans, locked beneath ice for 60 million years in the case of the Sturtian glaciation and 15 million in the Marinoan, were suddenly exposed. Great slabs of ice shattered and slid into the water, breaking apart with thunderous cracks that echoed across the continents. Where once the seas had been still and black, now floods of melt poured into them, stirring their layers, mixing ancient waters with sudden torrents of fresh runoff. The silence of ages was broken by chaos. The scale of the thaw is almost impossible to imagine. The glaciers that covered the continents were miles thick. When they collapsed, they released floods greater than anything seen since. Entire landscapes were drowned beneath surges of water, valleys scoured clean by torrents that carved new paths across the land. The weight of ice that had pressed down on the continents for millions of years lifted, and the Earth's crust rebounded, reshaping mountains and coasts. It was a planetary flood, not in myth or legend, but in stone and water. A deluge measured, not in years, but in cataclysmic bursts that remade the face of the Earth. In the oceans, the consequences were equally dramatic. Waters that had been sealed in darkness for eons were suddenly stirred by sunlight. Icebergs fractured and drifted, breaking apart as they melted, releasing vast amounts of trapped minerals into the sea. The chemistry of the oceans shifted almost overnight, transforming them from stagnant and lifeless basins into dynamic systems ready to feed the resurgence of life. Where once there had been only silence, now there was motion, mixing, and chaos. Imagine standing at the edge of one of these landscapes as the thaw began. Walls of ice taller than mountains collapse in slow, thunderous cascades. Rivers roar where none had flowed for tens of millions of years. Floods tear across plains, churning soil, stone, and water into torrents that reshape valleys in moments. The air itself grows heavy with moisture again, clouds gathering as evaporation returns. Rain falls for the first time in ages, washing the barren land, filling new rivers, and feeding the reborn water cycle. It was not a gentle return. The thaw was violent, destructive, and absolute, yet it was also the beginning of renewal. The greenhouse gases that had saved the Earth from permanent silence now unleashed a transformation that could not be stopped. The planet was pulled from its icy tomb and set once again into motion. Life, which had hidden in the smallest corners, would soon feel the consequences of this flood. The long stillness had ended, and the stage was being set for an explosion of change unlike anything the Earth had seen before. As the glaciers crumbled and the frozen surface of the seas split apart, the oceans that had been sealed in darkness for millions of years began to stir. For so long they had been divided into layers, the surface waters trapped beneath ice, cut off from air and sunlight, while the deeper waters grew heavy with minerals, stagnant and starved of oxygen. Nothing mixed, nothing moved. It was as though the seas themselves had been frozen in spirit, locked into silence, just as the land had been locked beneath snow. The thaw changed that in an instant. Floods of meltwater poured down from collapsing glaciers, rushing into the seas with unstoppable force. The weight of collapsing ice sheets sent pulses of energy through the oceans, overturning layers that had remained separate for tens of millions of years. Waters that had been isolated and toxic now surged upward, colliding with fresher meltwater and newly exposed surface layers. It was chaos on a planetary scale. These ancient deep waters carried chemicals that had been building slowly in the absence of circulation. Iron, sulfur, and carbon had accumulated in massive amounts, turning the deep into a poisonous brew. When the thaw forced those layers upward, they erupted into contact with sunlight and oxygen. The result was violent chemical reactions that transformed the oceans in a matter of centuries, a blink compared to the frozen ages that had preceded it. Oxygen, once scarce, flooded into the seas. For millions of years, microbes in hidden corners had produced oxygen as a byproduct, but with the surface sealed by ice, that oxygen had nowhere to go. Now, as the oceans overturned and mixed, that gas spread outward in sudden surges. Vast stretches of the sea that had been suffocating now stirred with breathable water again. Life, which had endured only in isolated refuges, suddenly found itself with room to expand. It must have been like the planet drawing its first breath after suffocation. Imagine the seas, once silent and black, exploding into motion as oxygen surged through them. Microbes multiplied with astonishing speed, feeding on the sudden abundance. Algae bloomed in the shallow waters, now free to feel the sun's light. Chains of life rebuilt themselves almost overnight, with organisms feeding on one another in waves of renewal. For the first time in tens of millions of years, the oceans were alive with energy. This rebirth was not gentle. The mixing of toxic waters with oxygen caused mass die-offs at first. Entire microbial communities that had adapted to stagnant conditions collapsed when exposed to oxygen-rich environments. But in their place, new life emerged, built for the changed world. Organisms that could use oxygen thrived, growing stronger and more complex, feeding on the chaos and building new ecosystems where the old had perished. Picture the transformation from above. The oceans, once dull and dark beneath their icy lids, now glitter with blooms of green and red algae spreading across the surface. Beneath them, microbial mats expand across rocks and vents, fed by oxygen they had not seen in ages. Larger organisms begin to appear, building webs of interaction more diverse than anything the frozen age had allowed. It was not just survival anymore. It was expansion, adaptation, and preparation for the complexity that would eventually follow. This sudden reawakening set the stage for what came next in Earth's history. The floods of oxygen, the bursts of new ecosystems, the collapse of some species, and the rise of others, all of it was a prelude. The planet had not simply thawed, it had been transformed. The oceans that had once been prisons were now laboratories of change, filled with potential, ready to push life toward forms it had never taken before. The silence of the frozen ages was gone. In its place came motion, color, and growth, as the seas reawakened from their long sleep and began to shape the next chapter of life on Earth. Even as the oceans surged back to life with oxygen and movement, the scars of the Great Freeze were not easily erased. 60 million years of deep cold during the Sturtian glaciation, followed closely by another 15 million during the Marinoan, had pushed life to its absolute limits. Entire lineages that had once drifted in the seas were gone forever, extinguished by the endless night. What remained was a planet populated not by abundance, but by survivors, a thin thread of existence carried forward by those who had endured in the darkest corners. Populations had collapsed to tiny remnants. Microbes that once spread widely across the oceans were forced into a handful of refuges, clinging to hydrothermal vents, geothermal pools, or perhaps in the thinnest stretches of equatorial seas, if open water ever existed. These survivors were not vast and varied communities. They were reduced to slivers of diversity, narrow strands of DNA passed down generation after generation through billions of cell divisions. The entire tree of life had been trimmed back to its barest branches. This reduction is what scientists call a genetic bottleneck. When most of a population is lost, only a small fraction of its genes carry forward. In normal times, diversity allows life to adapt in many directions at once. But in a bottleneck, diversity shrinks, and the survivors are forced to adapt with whatever traits remain. The danger is obvious. With too little variety, a single catastrophe could wipe everything out. Yet paradoxically, bottlenecks can also create resilience. They strip away the fragile, the vulnerable, leaving behind organisms hardened by the extremes they endured. Imagine those microbes multiplying in their tiny sanctuaries. For millions upon millions of years, every cell that survived had to tolerate crushing cold, total darkness, or toxic chemical environments. Those that could not adapt disappeared. Those that could persisted, carrying their traits forward. Over time, this relentless filtering forged resilience. The DNA of survivors carried instructions for endurance, for flexibility, for life at the very edge of possibility. It is humbling to realize how close everything came to ending. The world as we know it, forests, animals, humans, is built upon that narrow survival. If the bottleneck had been tighter still, if the refuges had failed, the story of life might have ended with microbes frozen in the dark. Instead, those survivors endured long enough for the thaw to arrive, and with it, an explosion of possibilities. Hardship, in this sense, became the mother of innovation. In the wake of the bottleneck, life did not simply return to what it had been. It began to experiment. Stripped down to its core, pushed by the demands of survival, life found new ways to grow. The simplest organisms began forming more complex structures, linking together in cooperation. Cells that had endured alone started to specialize, to share work, to create the first steps toward multicellularity. The trials of the deep freeze had primed them for change. Picture the moment after the thaw, when oxygen surged into the seas. Microbes that had been filtered through millions of years of hardship were suddenly given abundance. Instead of just surviving, they could expand. Their resilience, forged in scarcity, now became a tool for growth. They were strong enough to handle the chaos of mixing oceans, adaptable enough to exploit new environments, creative enough in the slow, evolutionary sense to invent new forms of life. The bottleneck did not just preserve life, it prepared it. What followed would be one of the most dramatic transformations in the history of the planet: the rise of complex life, the blossoming of diversity, the path that would one day lead to animals, plants, and eventually us. Yet all of that depended on these tiny survivors, huddled in volcanic shadows, whispering against extinction, carrying the story forward when almost everything else was lost. The Earth had pressed life against the edge, reducing it to remnants, narrowing its possibilities, testing its endurance, and in that crucible, resilience was born. Out of the silence of the Snowball Earth came not only survival, but the seeds of the next great leap forward. The Great Thaw did more than end an age of ice. It opened the door to one of the most remarkable chapters in the history of life: the Cambrian explosion. Only tens of millions of years after the glaciers retreated, the seas that had once been silent and dark were suddenly filled with an extraordinary diversity of creatures. It was as if the world, having endured its longest winter, awoke not just to survive, but to create. Before Snowball Earth, life had been simple. For billions of years, microbes dominated the planet, shaping its chemistry and atmosphere, but never developing much complexity. They were abundant, but they were limited in form, largely invisible mats and colonies spread across the oceans. But after the thaw, something shifted. The fossil record shows that around 540 million years ago, life began to diversify at a pace never seen before. Creatures with shells, skeletons, and complex bodies appeared in a geological instant. Entire ecosystems burst into existence, filled with predators and prey, grazers and burrowers, builders and hunters. The Earth, long silent in form, had found its voice in living shapes. Why did this explosion happen when it did? Many scientists believe the ordeal of Snowball Earth played a crucial role. The extreme stress of surviving 60 million years of ice, followed by another 15 million in the second freeze, may have acted as a crucible. Those bottlenecks of survival forced life to adapt in ways it never had before. Microbes that endured had been hardened by scarcity, trained by constant struggle to make the most of every resource. When the thaw came and the oceans were suddenly rich with oxygen and nutrients, those survivors were primed to take advantage. It is easy to imagine the scene. The seas, once starved of oxygen, now surged with it, as circulation returned and photosynthesis bloomed in sunlight. Nutrients that had built up in the deep over millions of years now mixed into the surface waters. For the organisms that had survived in the shadows, it must have felt like stepping into a paradise. With energy and resources suddenly abundant, evolution accelerated. Life that had been constrained for so long now had the means to experiment. Cells linked together into more complex structures. Bodies developed skeletons for protection, eyes for hunting, and mouths for feeding. This explosion of diversity may never have happened without the crucible of the ice ages. Snowball Earth had stripped life down to its barest essentials, leaving only the most resilient lineages. Those lineages, forged in the fires of hardship, were uniquely suited to thrive in the abundance that followed. The stresses of the deep freeze may have been the spark that ignited complexity, the reason why multicellular life did not just emerge, but flourished in dramatic fashion. The Cambrian explosion was not just about variety, it was about possibility. Entire body plans that still shape the animal kingdom today were established in those seas. The ancestors of worms, arthropods, mollusks, and vertebrates all appeared in that burst of creativity. Without it, the evolutionary path that eventually led to fish, amphibians, reptiles, mammals, and humans might never have unfolded. To think of it in human terms is staggering. Without Snowball Earth, Without the hardships of those frozen millions of years, there might never have been the complexity necessary for intelligence to arise. No forest to walk through, no animals to paint on cave walls, no humans to look up at the stars and wonder. The very existence of thought, of consciousness, may trace back to the silent endurance of microbes huddled in the darkness beneath glaciers. The Cambrian explosion is often seen as life's great awakening, a sudden bloom after billions of years of simplicity. But in truth, it was the culmination of trials that came before, of bottlenecks that stripped away the fragile and left only the resilient. It was the reward for survival in the face of impossible odds. The Earth had pressed life against the edge of extinction, and life had not only endured, it had emerged stronger, ready to take on shapes and forms that would define the rest of history. The seas of the Cambrian would have been a dazzling sight, filled with creatures never before imagined. Trilobites scuttled across the ocean floor, worms burrowed into the sediment, spiny predators drifted through the currents, while soft-bodied grazers fed on algae. Eyes glittered for the first time in the seas, watching, hunting, surviving. It was a world alive with color, movement, and competition, a world born out of the silence of Snowball Earth. The story of Snowball Earth does not belong only to our planet. It is also a window into the possibilities of life beyond our world. When we look across the solar system today, we see other icy bodies that seem cold and lifeless on the surface, yet beneath their frozen crusts may lie oceans as vast as Earth's body. The survival of life through Earth's own deep freezes offers a powerful lesson. If microbes could endure for tens of millions of years beneath ice here, perhaps life could also persist beneath the ice of distant moons. Two of the most compelling examples are Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. Both are small compared to Earth, yet each is wrapped in ice so thick that their surfaces gleam like frozen mirrors. At first glance, they appear silent and barren, much as Earth would have looked during its snowball phases. But scientists believe that beneath those icy shells, liquid oceans remain, kept from freezing solid by the heat of tidal forces and internal geology. Just as Earth's hidden volcanic vents nurtured life in the dark, these alien oceans may also harbor the chemistry of survival. Europa's surface is marked with cracks and streaks, long scars etched into its ice by the stresses of Jupiter's pull. Beneath that shell, an ocean may extend for tens of miles in depth, containing more water than all of Earth's seas combined. If that ocean is real, it is shielded from the vacuum of space by its icy lid, yet stirred from below by volcanic activity and chemical mixing. For life, that combination could be enough. Earth's microbes thrived in vents where heat and chemistry replaced sunlight, and the same might be possible on Europa. Enceladus, though smaller, has already given us even more tantalizing hints. Geysers burst from its south pole, spraying plumes of water vapor and ice crystals into space. When spacecraft have passed through those plumes, they detected organic molecules and salts, the same ingredients that make up Earth's oceans. The tiny moon is venting its hidden sea into the cosmos, whispering of an ocean beneath its crust. If there is volcanic activity at the seafloor of Enceladus, as many scientists suspect, it would create the same conditions that sustained Earth's earliest survivors, chemical energy in a sunless sea. Snowball Earth shows us that ice does not always mean lifelessness. During the Sturtian and Marinoan glaciations, Earth was locked in ice from pole to equator. From space, it would have looked indistinguishable from Europa or Enceladus, dazzling white and silent. Yet beneath its frozen surface, life endured, clinging to hydrothermal vents, geothermal pools, and chemical oases. What appeared dead from afar was, in truth, still alive. This is why we look to icy moons with such fascination. Their surfaces may conceal secrets, just as Earth's ice once did. It is a profound thought. Somewhere beneath Europa's ice, microbes may gather around vents, building mats of life that glow faintly in the darkness. Somewhere in the oceans of Enceladus, strange chemistries may weave chains of molecules, forming the first fragile steps toward living systems. These worlds may be laboratories of survival, echoing what happened on Earth nearly 700 million years ago. When we study Snowball Earth, we are not only uncovering our own history, but also testing a blueprint for survival in the cosmos. We are learning that life does not need warmth from the sun, that it can persist in darkness if there is energy and chemistry. The lesson is simple but powerful. Where there is water, where there is heat, where there is the possibility of reaction, there may be life. Earth itself proves survival in the unlikeliest of places. The fact that our planet looked like a frozen exoplanet, yet secretly kept its story alive beneath the ice, should make us cautious about dismissing other frozen worlds. What looks lifeless from a telescope may only be hiding its resilience below the surface. The echoes of Snowball Earth reach far into the solar system, reminding us that the struggle of life is universal, and that endurance in the face of impossible odds may be written across many worlds, not just our own. The tale of Snowball Earth might sound like something out of myth, a story too strange to be true. Yet, the evidence is not hidden in imagination, but in the very bones of the planet. Rocks, silent and ancient, carry within them the fingerprints of this deep freeze. They whisper of glaciers that reached the tropics, oceans that vanished beneath ice, and life that endured in secret. Every stone that scientists split open, every cliff face they study, is a page in the oldest book ever written. One of the clearest signs comes from dropstones. These are chunks of rock, often large and out of place, found buried in layers of fine sediment where they do not belong. The only way they could have arrived there is if they were carried by ice. A glacier would grind a stone into its belly, hold it tight as it floated in an iceberg, and then release it when the ice melted into the sea. Today, dropstones are found in cold regions like the Arctic and Antarctic. But the strange thing is, during Snowball Earth, they are found in rocks that formed near the equator. That means glaciers were not confined to the poles. They stretched all the way into the tropics, dragging stones with them and dropping them into warm seas that should never have known ice. These scattered stones, frozen in place for hundreds of millions of years, are proof that the Earth was once wrapped in glaciers from edge to edge. Other evidence is locked in chemistry, in isotopes that act as subtle markers of ancient conditions. Carbon isotopes, in particular, reveal changes in how life and the environment interacted. During the frozen ages, the ratios of carbon isotopes shifted dramatically, showing that the normal cycles of life had nearly collapsed. Photosynthesis slowed to a whisper, yet the isotopes also prove that it never ceased entirely. They carry the faint signature of microbial survival, the breath of life recorded in stone, even when the surface world was locked in silence. These microscopic fingerprints are delicate, but they are undeniable. They tell us that life clung on, not everywhere, but in rare sanctuaries, waiting for the ice to pass. Perhaps the most haunting clues of all are the layers of carbonate rock known as cap carbonates. These appear directly above glacial deposits, forming a sharp boundary between ice and thaw. They were laid down rapidly when the world emerged from its frozen prison. As the glaciers melted, the oceans filled with carbon dioxide that had been trapped in the atmosphere for millions of years. That sudden flood of greenhouse gases caused a chemical storm in the seas, precipitating vast amounts of carbonate that settled as thick, distinctive layers. These rocks are global, found on every continent, and they mark the exact moment when the Ice Age ended. They are like a geological exclamation point, shouting across time that the Earth thawed in a violent and sudden release. For scientists, piecing together these clues is like reconstructing a puzzle with most of the pieces missing. Dropstones tell of glaciers reaching the equator, isotopes whisper of survival in hidden corners. Cap carbonates reveal the drama of the thaw. No single piece is enough, but together they form a picture too consistent to ignore. Across continents and oceans, the rocks repeat the same story, as if the Earth itself is determined to remind us of the trials it once endured. Imagine a geologist standing before a sheer cliff face, tracing their hands across the bands of stone. Each layer is a chapter, each mineral a sentence. Here, a dropstone marks the reach of ice. There, an isotope ratio whispers of microbial life persisting against the odds. Above it all, a bright band of carbonate announces the thaw. These rocks do not speak with words, yet they carry a language older and more enduring than any spoken by humans. They are the storytellers of time, preserving the memory of a world that nearly ended. The evidence is not gentle, nor is it vague. It is stark and physical, cut into cliffs, scattered in sediments, etched into isotopes. Together, they leave no doubt that the Earth was once a snowball, that life endured its silence, and that the scars of that age remain written in stone. When we picture Snowball Earth, it is easy for our imagination to drift toward images shaped by myths, movies, or fragments of schoolroom lessons. A planet dusted in white like a winter postcard, dinosaurs trudging through icy forests, fluffy snow falling gently across frozen valleys. These images are powerful, but they are also misleading. To truly understand what happened hundreds of millions of years ago, we need to peel away the myths and replace them with the reality revealed by science. The first and perhaps most common misconception is when Snowball Earth actually occurred. Many people imagine it as something that happened during the time of the dinosaurs, as if giant reptiles endured an Earth sealed in ice. But Snowball Earth was far older than that. It took place during the Cryogenian period, between roughly 720 million and 635 million years ago. Dinosaurs, in comparison, only appeared around 230 million years ago. They missed these cataclysms by nearly 500 million years. When Earth was locked in its frozen ages, the land was barren of forests. There were no animals roaming, no insects buzzing. Life was still microscopic, confined to simple algae and bacteria drifting in the seas. The dinosaurs, the forests, the mammals, and eventually humans would not arrive until much, much later. Another misconception comes from how we picture the ice itself. The term Snowball Earth tempts us to imagine a world blanketed in powdery, fluffy snow, like the soft drifts of a northern winter. But the reality was far harsher. This was not a thin blanket of snow. It was a planet encased in glaciers. The ice was thick, crushing, and unyielding. In many places, it may have been miles deep, pressing down on the oceans beneath, sealing them in darkness. Where we might picture frosted trees or snow-covered mountains, the truth is closer to an alien landscape of frozen cliffs, endless white plains, and towering sheets of ice grinding slowly across the continents. This was not a gentle snowfall. It was a suffocating glacier stretching across the world. Even the skies were different from how we might imagine them. A modern snowstorm brings clouds and flakes drifting lazily from above. But during Snowball Earth, With the water cycle broken, there would have been little snow at all. The skies would have been eerily clear, pale and dim under the weak Sunday. What covered the earth was not the product of storms, but the slow, relentless spread of glaciers, inch by inch across the land, swallowing everything in their path. It was silence, not snowfall, that defined the world. Another myth is that Snowball Earth was a single event, a one-time freeze that came and went. In truth, it was a series of catastrophes. The longest, called the Sturtian glaciation, lasted around 60 million years, followed closely by the Marinoan, which endured for another 15 million. These were not brief cold snaps, but apocalypses that spanned more time than entire eras of later life. The reality is that the Earth froze, thawed, and froze again, testing life not once but twice in quick succession. Even the name Snowball Earth can be misleading. It suggests something smooth, simple, and perfectly round, like a child's toy. But the true planet would have been jagged and raw. Glaciers carved valleys, crushed mountains, and scoured the continents. The seas beneath were black and still, starved of sunlight. From space, the Earth may have looked like a dazzling white sphere, but up close it would have been brutal, alien, and inhospitable. Correcting these images is not just about accuracy, but about appreciation. When we realize that dinosaurs were not there, that forests did not exist, that this was a planet of bare rock, ice, and microbes, the scale of the survival story becomes even more powerful. Life endured in a world without comfort, without beauty, without warmth. It endured not under fluffy snowflakes, but under crushing glaciers, beneath skies emptied of clouds, in oceans sealed in darkness. That survival is what carried forward the potential for everything that came later: forests, animals, civilizations, and us. When we think of Snowball Earth, it feels like a story that belongs only to the distant past, a frozen nightmare locked away hundreds of millions of years ago. Today, we look around and see a planet moving in the opposite direction. Instead of ice advancing across the continents, glaciers are retreating. Instead of oceans sealed under miles of ice, seas are rising as the world warms. Yet the very same forces that once plunged Earth into silence are still present, still at work, and still capable of tipping the balance in ways we may not expect. The haunting question lingers: could it happen again? At first glance, the answer seems impossible. Earth is heating, not cooling. Carbon dioxide levels are climbing, not falling. Human industry has pumped vast amounts of greenhouse gases into the sky in only a few centuries, enough to overwhelm the slow, natural rhythms that once ruled the climate. The planet today is moving away from the conditions that created Snowball Earth, and yet, climate is not a simple machine. It is a balance, fragile and unpredictable, capable of flipping from one extreme to another with startling speed. Theoretically, if greenhouse gases were to collapse rather than increase, Earth could still find itself pushed back toward the edge of ice. Carbon dioxide is not simply pollution. It is a key part of the atmosphere's ability to trap heat. Without it, warmth slips away into space, and the Earth cools. If for some reason the concentration of greenhouse gases were to plummet, the same runaway cycle that once gripped the planet could repeat. Ice would advance, reflecting sunlight back into space, and the cold would deepen with each passing year. What could cause such a collapse? In the ancient world, the breakup of supercontinents exposed fresh volcanic rock that absorbed carbon dioxide from the atmosphere like a sponge. The process of weathering slowly stripped the air of its greenhouse gases, pulling the climate toward catastrophe. In theory, something similar could happen again if new continents rose, or if vast new mountain ranges were exposed to rain and erosion. Even now, carbon dioxide is absorbed by rocks and oceans, though not at the scale required to trigger a global freeze. But the principle remains: remove enough greenhouse gases, and even under a stronger sun, the Earth could slip once more into ice. What makes the idea so haunting is not its likelihood, but its reminder of fragility. The balance that sustains life is not guaranteed. A few changes in the wrong direction, and the seesaw could tip. Today, we are pushing it toward heat, but the same knife's edge could, in another age, tilt back toward cold. The Earth has already shown us that it is capable of both extremes, that it can be a greenhouse world or a frozen tomb, depending on the smallest shifts in gases, sunlight, and geology. Imagine standing far in the future, looking up at a pale sun through a thin atmosphere, watching as glaciers creep once again across the tropics. The seas fall silent, the skies lose their clouds, and the world becomes white and breathless. To us now, such a vision seems unreal, overshadowed by the dangers of warming. But the memory of Snowball Earth whispers that the planet has not forgotten how to freeze. Our time is one of heat, not cold. Yet the lesson of the past is clear. Stability is fragile. Earth is not locked into comfort. It can swing, suddenly and violently, between states that make life nearly impossible. And knowing that it once froze solid for tens of millions of years makes the possibility, however remote, all the more haunting. When we look back at Snowball Earth, it is tempting to feel a kind of safety, knowing that the planet escaped its icy tomb. The glaciers retreated, the oceans reawakened, and life eventually flourished in dazzling complexity. But it is worth pausing to imagine the darker possibility, the path history almost took. What if the Earth had not thawed? What if the volcanoes had fallen silent? If greenhouse gases had not built up? If the sun's faint warmth had never been enough to tip the balance back toward life? The answer is chilling. Life would have ended with microbes, tiny organisms clinging to volcanic vents and chemical oases, trapped in darkness until the last sources of energy flickered out. There would have been no plants reaching for the sun, no forests breathing life into the air, no animals crawling, swimming, or flying across the planet. The vast evolutionary story we know would have been cut short in silence, erased before it began. Picture such a world. The Earth remains sealed in white, its continents buried beneath miles of glaciers, its oceans black and starved beneath unbroken lids of ice. From space, the planet shines like a frozen pearl, dazzling and lifeless, a perfect snowball adrift in the void. On the surface, silence reigns. No rivers cut through valleys. No rain falls from the sky. The air is thin, bitterly cold, and empty of sound. Beneath the ice, life persists for a while. Microbes cluster in thin mats around hydrothermal vents, where heat and chemicals rise from the planet's restless interior. They feed on sulfur and hydrogen, reproducing slowly in the dark, but their world is small, fragile, and finite. Without circulation, the oceans stagnate. Without a thaw, oxygen never surges back into the seas. Without sunlight, photosynthesis never expands again. Slowly, over unimaginable spans of time, even these refuges would fail. The deep freeze would tighten its grip until not a single living cell remained. No plants would ever spread across the land. The continents would stay barren, their soils locked under ice. No green forests would breathe oxygen into the atmosphere. No flowers would bloom, no roots would split stone, no seeds would scatter on the wind. The air would remain thin, empty of the richness that makes breathing possible. No animals would ever appear. There would be no trilobites scuttling across the ocean floor, no fish darting through shallow seas, no reptiles basking on rocks, no mammals huddling for warmth. The seas would remain silent, the land forever bare. The Cambrian explosion, that great bloom of diversity, would never happen. The path toward eyes, skeletons, wings, and brains would never begin. Evolution's canvas would stay blank, its colors never painted. And of course, without that explosion of life, there would be no humans, no hands to carve tools, no voices to sing or speak, no minds to wonder at the stars. There would be no history, no memory, no stories. The earth would be a frozen monument to what could have been, a reminder of how close the story of life came to ending before it had the chance to unfold. This alternate world is not just a thought experiment, it is a glimpse into a fate that was possible, perhaps even likely. The planet was caught in a trap that could have been permanent. Only the slow, patient breath of volcanoes, releasing greenhouse gases into the sky, pulled it back from the brink. Without that fragile escape, Earth would have joined the countless frozen worlds we see in the cosmos, planets that may never have had the chance to spark with life at all. It is humbling to think how narrow the margin was. Our existence depends on a delicate balance that nearly failed. Had the glaciers never retreated, we would not be here to ask these questions, to imagine these histories, to look back on a frozen world and call it our past. The Earth would still be there, silent and shining, but its story would have ended with microbes whispering in the dark. The story of Snowball Earth might feel impossibly distant, buried in the depths of time, yet it carries a message that is painfully relevant today. What those frozen ages show us is that climate is not stable and unshakable, but fragile, always perched on a knife's edge. The balance that kept Earth habitable then is the same balance that sustains us now, and it does not take much to tip it one way or the other. In the Cryogenian, the planet slipped into ice because greenhouse gases fell too low. Today, we face the opposite danger, pushing the atmosphere in the other direction with startling speed. Think of climate as a seesaw. In the past, small changes in the tilt of that balance sent the Earth spiraling into cold. Carbon dioxide levels dropped, sunlight reflected off growing ice sheets, and feedback loops carried the planet into catastrophe. Now, the tilt is the other way. Human activity has released immense amounts of carbon dioxide, methane, and other greenhouse gases into the atmosphere, raising their levels far beyond anything seen in millions of years. Instead of slipping into ice, the seesaw is tipping toward heat, and just as it did before, feedbacks are amplifying the change. Melting permafrost releases more carbon. Shrinking glaciers reduce the Earth's reflectivity, trapping more heat. Droughts and wildfires strip away forests that once absorbed greenhouse gases. The haunting lesson is that the fragility is the same. In one age, too little carbon dioxide nearly ended life in silence and ice. In our age, too much threatens to overheat the planet, drown coasts, and destabilize ecosystems. The details are different, but the principle is identical. Earth's climate is delicately balanced, and small shifts can become unstoppable once feedback loops take hold. Snowball Earth warns us how easily that balance can break. Imagine if our ancestors could have seen the Cryogenian ages when glaciers smothered the tropics and the oceans froze to their depths. They might have thought the planet was uninhabitable forever, yet the balance eventually tipped back. Volcanoes and greenhouse gases pulled Earth out of the freeze. Life survived, but only barely, passing through a bottleneck so narrow that extinction hovered constantly overhead. Now we are the ones pressing on that balance, not with geology unfolding over millions of years, but with factories, cars, and cities altering the air in just a few centuries. It is astonishing to realize how quickly we have shifted the atmosphere compared to the deep past. During the Cryogenian, it took millions upon millions of years of rock weathering to strip enough carbon dioxide to trigger a global freeze. In our age, in just a few hundred years, human industry has raised atmospheric carbon dioxide to levels not seen in at least 3 million years. The scale of change that once demanded continents breaking apart and volcanoes erupting endlessly has been matched by the burning of coal, oil, and gas. That speed is what makes our moment so precarious. The planet can adapt slowly, but when changes come too quickly, the balance breaks. The lesson of Snowball Earth is not only about ice, it is about fragility. It shows that life on this planet has always been vulnerable to climate swings. It survived the frozen ages only by clinging to refuges, and when the thaw came, it was transformed. For us, the warning is clear. If we continue to push the climate further into imbalance, we may survive, but what emerges may be unrecognizable, with ecosystems collapsing, coastlines shifting, and entire ways of life forced to adapt. Snowball Earth reminds us that stability is not guaranteed. The balance can be broken. And just as the glaciers once reached the tropics, our choices today could set in motion feedbacks that reshape the world for generations to come. The frozen ages show us that the Earth does not forgive imbalance easily. It reacts, it amplifies, and it transforms. What is at stake is not the planet itself. The Earth will endure, but the thin layer of life, including us, that depends on its fragile equilibrium. When the Great Thaw finally arrived, the transformation was overwhelming. For tens of millions of years, Earth had been locked in silence, its continents smothered under glaciers, and its oceans sealed away from the sunlight. Then, in what must have felt like an instant compared to the deep freeze, the planet stirred. Ice retreated, oceans surged, and the atmosphere filled with new breath. It was not a simple return to what had been before. The thaw reshaped everything. Oceans, atmosphere, and continents all bore the marks of change. The Earth that emerged was not the same Earth that had been buried beneath the ice. The oceans were among the first to feel the rebirth. As the glaciers melted, torrents of water poured into the seas, mixing surface and depth in violent currents. Layers that had been stagnant for ages suddenly overturned. Nutrients trapped in the deep were released upward, feeding bursts of new growth. Oxygen, once scarce, now spread through the water, transforming it from a suffocating basin into a living sea. Algae flourished in sunlight, spreading across the surface in brilliant blooms. Food webs reformed almost overnight, microbes giving way to more complex organisms as life expanded into every corner of the oceans. The atmosphere, too, was remade. For millions of years during the freeze, volcanoes had been releasing carbon dioxide without interruption, and with no active water cycle to absorb it, the gas had built up in staggering amounts. When the thaw came, this greenhouse blanket drove temperatures higher than they had been in a very long time. The Earth went from ice to heat with shocking speed. Evaporation returned. Clouds filled the skies, and rain fell again, washing the continents and carving new rivers. Lightning flickered across storms, and winds carried fresh air into places that had been still for ages. The air was heavy with carbon dioxide at first, but with the return of oceans and photosynthetic life, it began slowly to shift, stabilizing into an atmosphere that could support greater diversity. Even the continents themselves were reborn. Glaciers are not gentle in their grip. For tens of millions of years, ice sheets had scraped the land, grinding mountains down, carrying stones across valleys, and scouring the surface with unimaginable force. When the ice withdrew, the continents looked different. Valleys were widened, plains stretched bare, and deposits of strange rocks were left behind, carried from faraway places. As the crust rebounded from the weight of the glaciers, mountains rose again, new coastlines formed, and the stage of Earth's surface was rearranged for the next acts of life. Out of this reshaped world, life returned stronger. The microbes that had survived the freeze were not fragile. They had been tested by conditions almost no planet escapes from. They were resilient, flexible, and inventive. Now, in a world rich with oxygen and nutrients, they grew in complexity. Cells began to cooperate in ways they had not before. Some formed colonies, others specialized into different roles. The seeds of multicellular life that had been present before the freeze now found fertile ground to expand. What had been simple mats of microbes became the foundation for more elaborate structures, leading, in time, to the diversity of the Cambrian explosion. It is difficult not to picture the Earth as a kind of phoenix in this age, rising from the ashes of its own icy destruction. The freeze had nearly silenced it forever, but in thawing, the planet emerged transformed. The seas were richer, the skies more dynamic, the continents freshly sculpted. Life itself had passed through fire and ice, and what came out on the other side was not just survival, but preparation for greatness. The resilience written into the DNA of survivors would fuel the rise of complexity, diversity, and eventually, intelligence. From silence and ice came motion and sound. From stillness came storms and rivers. From scarcity came abundance. The rebirth was not gentle, but it was profound. Earth had remade itself, and life had been remade along with it. The frozen world had not been the end of the story, but the crucible in which the next chapter was forged. Close your eyes and imagine standing on the surface of Earth during the height of its frozen age. The ground beneath your feet is not soil or sand, but solid ice that stretches endlessly in every direction. Mountains are buried under gleaming white sheets, their jagged peaks dulled and swallowed by glaciers miles thick. Valleys that once held rivers are sealed, flat and featureless, covered by frozen silence. The horizon glitters under a weak and distant sun, its rays pale, unable to warm the air. There is no green anywhere, no forests, no grass, no algae-streaked shallows to break the monotony of white. There is no blue of open ocean reflecting the sky, no deep waters rolling in waves. Instead, the seas themselves lie hidden beneath an armor of ice, their surface indistinguishable from the continents. The entire world has become one continuous landscape of silence, as though color itself has been erased. The air is painfully cold, sharper than anything we can imagine today. Breathing feels heavy, as if the air carries no warmth, no softness. Winds whip across the surface, dry and hollow, lifting fine particles of snow that sting like glass against the skin. The sound of the world is gone. There are no rivers rushing, no rainfall tapping the ground, no forests rustling in the breeze. The only noise is the groan of ice shifting, the sudden crack of glaciers breaking apart in slow motion, echoing across the emptiness like distant thunder. From space, the planet is even more haunting. The Earth does not shine with its familiar blues and greens. Instead, it gleams like a frozen pearl, a white sphere reflecting nearly all the light of the Sunday. It looks lifeless, a world locked in stasis, no more alive than the icy moons of Jupiter or Saturn. To an observer watching from afar, there would be nothing to suggest that life persisted at all. The Earth would appear to be a silent world, sealed in death, yet beneath this frozen armor, hidden from sight, life whispered in defiance. In the blackness under the ice, the ocean still stirred faintly. Around volcanic vents on the seafloor, microbial mats clung stubbornly to survival, feeding not on sunlight but on the chemistry of the Earth itself. In geothermal pools, tiny organisms adapted to heat and scarcity, multiplying slowly, generation after generation, carrying the spark of existence through the longest night the planet had ever endured. It is a sobering thought to realize how fragile that spark was. A few more degrees of cold, a few more million years of silence, and even those hidden refuges might have vanished. But they did not. Against the crushing ice, against the darkness, against the stillness of a frozen sea, life held on. To stand in that world would be to feel both despair and awe at once. Despair at the overwhelming emptiness, awe at the knowledge that beneath it, something was still alive. Picture yourself kneeling on that ice, pressing your hand against its hard, translucent surface. Beneath, though you cannot see it, tiny microbes move in their invisible worlds. They are too small to notice, too small to comfort you, yet they are there. Their existence is a whisper in defiance of the silence above. They carry the story forward, unaware of the vast future that depends on their endurance. This frozen earth, devoid of green or blue, stripped of warmth and sound, was not the end. It was the crucible in which life proved its resilience. And though the world above was nothing but ice and silence, beneath it was a quiet persistence, an unbroken thread stretching through the darkness, waiting for the day the thaw would come. For 60 million years, the world was locked in a prison of ice. Entire continents were buried beneath glaciers. Oceans lay sealed beneath frozen lids, and the skies themselves were stripped of clouds and rain. By all logic, life should have ended there. The odds were impossibly small, the conditions unimaginably harsh, and yet, against all reason, life endured. This endurance was not grand or dramatic. There were no great forests, standing tall against the cold, no animals clawing through the snow to find shelter. Survival belonged to the unseen, the smallest and simplest forms of life, hidden in places where warmth and chemistry still lingered. Microbes huddled in the shadows of hydrothermal vents at the ocean floor, feeding on the minerals that gushed from the Earth's interior. Others found refuge in geothermal pools, where volcanic heat kept tiny sanctuaries alive. Some may have endured in thin cracks of open water near the equator, where ice was thinner and light still barely touched the sea. Generation after generation, they clung on. Each cell carried forward the thread of existence, dividing and multiplying, adapting to the eternal night. They faced shortages of nutrients, fluctuations in heat, and endless time without the comfort of sunlight. Yet they endured, because to survive is the most basic drive of life, written into the very chemistry of every living thing. It is staggering to think that every plant, every animal, every human today exists because of that endurance. The resilience written into those ancient microbes did not vanish with the thaw. It is written into our DNA, the ability to adapt, to withstand hardship, to continue when conditions seem impossible, is not just a story of the past, but a living inheritance. Every breath we take carries within it the triumph of those long-dead cells that refuse to disappear in the dark. Imagine tracing your family tree back, not through centuries or even millennia, but through hundreds of millions of years. Each branch would narrow and narrow until it reaches those microscopic survivors. They are our ancestors, just as surely as our grandparents and great-grandparents are. Without them, there would be no forests, no oceans filled with fish, no birds in the skies, no humans to wonder about the stars. We are the children of survivors of ice. The miracle lies not only in the fact that life endured, but in how it emerged stronger for having endured. The hardships of Snowball Earth acted like a crucible, forging resilience. When the thaw finally came, those survivors were ready. They had endured scarcity, so abundance pushed them into new forms. They had adapted to darkness, so sunlight gave them room to grow. Their resilience prepared them to take advantage of the new world, leading to the burst of diversity that followed, and eventually to the rise of creatures with eyes, bones, wings, and minds. Even now, when we look at life around us, we see traces of that survival. Microbes that thrive in volcanic vents or boiling springs are echoes of their ancient cousins, reminders of what life is capable of. The genes that allow humans to adapt to heat, cold, altitude, and scarcity are part of that inheritance. The resilience that allowed life to survive 60 million years of frozen silence still whispers in our biology, proof that we are not just fragile beings, but the outcome of unimaginable endurance. The story of Snowball Earth is not just one of catastrophe, it is a story of persistence, of survival in the face of certain doom. It shows that even in the most hostile conditions, life can find a way to continue, to adapt, to endure. And it is because of that miracle, carried forward through time, that we stand here today, breathing, thinking, and remembering the silence of ice that nearly ended everything. When we look back across the history of our planet, it is easy to forget just how improbable our existence truly is. Earth has been through fire, through floods, through extinctions, and through freezes so complete they nearly silenced life forever. Yet among all of those trials, none stand out quite like the age of Snowball Earth. For 60 million years, the world was locked in ice. Entire oceans were sealed beneath glaciers. Skies lost their clouds, rivers lost their flow, and continents lay smothered in frozen silence. By all rights, life should have ended there, but somehow it did not. That survival is nothing short of impossible, against crushing cold, against starvation, against a night that lasted longer than humanity has even existed. Life endured. Tiny microbes, hidden in cracks of warmth beneath the ice, carried forward the thread of existence when everything else seemed lost. They survived not for a day, or a year, or a century, but for tens of millions of years. They endured conditions that would destroy almost anything we know today. And from that fragile survival came everything that followed: forests, animals, oceans alive with color, and eventually humans. The fact that you and I are here at all is because Earth thawed, because volcanoes breathed out gases that warmed the skies, and because those tiny organisms held on long enough for renewal. Without them, there would be no plants to paint the continents green, no animals to swim or run or fly, no people to wonder at the stars or to sit quietly listening to this story. Without the miracle of survival beneath the ice, there would be no us. It is humbling to think of ourselves as the descendants of survivors who clung to life in darkness. Written in our DNA is a record of resilience, the echo of endurance through impossible odds. Every breath we take, every thought we form, is only possible because life refused to give up in an age when the planet itself seemed determined to erase it. Snowball Earth is not just a chapter of catastrophe, it is also a chapter of hope, reminding us that life can bend without breaking, that even in silence and ice, persistence is possible. And so I leave you with a question, one that is both haunting and personal. Would you have survived Snowball Earth? Could you have endured a planet sealed in frozen silence, with only the faintest cracks of warmth to cling to? Perhaps the truer answer is that you already have, because inside you is the inheritance of those survivors. Their resilience is your resilience. Their triumph is your triumph. You are here because they whispered against extinction and carried the story forward. If this journey through Earth's frozen past has stirred your imagination, if you find comfort in exploring these impossible stories of science with me, I would be so grateful if you left this video a gentle like and maybe tapped subscribe. It helps this quiet corner of the internet reach more curious minds, more dreamers, more people who love drifting into the mysteries of our world. And if you feel called, share in the comments where are you listening from tonight, and what time is it there. I love seeing how far these soft journeys travel, how we are all connected by the same story, even when scattered across the world. So take a deep breath, let your shoulders soften, let your eyes grow heavy, and carry with you the wonder that we are here, not by chance, but by the miracle of survival. Life endured 60 million years of ice, and because of that, you are here, breathing, listening, dreaming. The story continues, and together we will keep exploring the impossible.